Hello and welcome to today's webinar. My name is Ted Stewart, and today's webinar is going to be on the evolving IEC 62443 Cybersecurity certification. Like you see there, I am a CFSP. I'm the Program Development and Compliance Manager here for exida. I have about 10 years of experience in safety and high availability automation systems, manufacturing, lean process improvement. I started my career with Lockheed Martin in missiles and fire control as a test engineer. Had a lot of fun there. I then transitioned over to a sister company, Harris Corporation, where I worked in wireless product group. We basically made little black boxes that could locate and track people. That was even a lot more fun. And then my wife and I then transitioned over to exida and have been here since, I think, 5 or 6 years now. My responsibilities here for exida: I'm managing the OEM certification division. I'm the deputy quality manager and also the director of the CFSP program. So it's a lot of fun. I get to wear a lot of different hats, and every day is a new experience, and it's a new challenge because of so much that's going on. Who we are: we always do a few introduction slides for the newcomers. And we were founded in 1999 by several of the world's top reliability and safety experts, Dr. William Goebel and Mr. Rainer Faller. Dr. Goebel was in the Americas, and Rainer Faller was in Germany. They saw a need in the market, decided to start exida, and here we are today, growing rapidly. But you know, we do anything in functional safety, alarm management. In today's webinar, of course, we're getting heavily involved in cybersecurity. Now, exida, we're involved with the complete supply chain of functional safety and cybersecurity in different industry sectors, from the original equipment of the manufacturers who require this product certification, even to their customers, the end users that use the products. Now, we provide, and you'll see in the next slide, we provide software tools, training, consulting, and procedures related to functional safety, cybersecurity, and reliability. If you see this slide, think for a moment, you know, how can exida help you? What are you spending a lot of your time, effort, and money in? Do you need help maybe on site? Do you spend time working out equations and building your own SIFs? Do you have products that could or are being used in a safety system? So basically, whether it's machinery, it's robotics, it's cybersecurity, alarm management, you know, I like to challenge everyone to just ask the question and see how we can assist. We do have a suite of products you see in front of you, whether it's consulting, the engineering tools, the product certification, the training, the reference materials, or even for your own sake, the professional certification, professional certification, sorry, for people. We kind of do a little bit of everything, but we're in our tight niche market. And you know, the interesting thing is when my wife and I were considering working for exida, you know, we had a great job already, and we wanted to make sure that this company was going to be around for a long time. Well, if a company's been around for, I guess now 20 years, it was 15 at the time, and they've taken over 66% of the market share in the certification market, that's kind of a good sign. So yeah, we've been very busy. I can see why now working for the company. A lot of us sometimes don't sleep. No, we work very hard. We're laser focused in this industry. Our founder, Dr. Goebel, he eats, he sleeps, he lives this industry. He loves what he does, and it's so much fun working for someone that cares as much as he does. All right, so now let's go into cybersecurity, and let's talk about it. So why worry about cybersecurity? Well, 3 easy bullet points here. You have the modern CIS and the BPCS communicate, and they usually communicate via the process control network. And anytime I use an acronym, I try and pronounce it at the bottom there. So if you don't know what a BPCS is or a CIS is, you can, you know, that will at least help you there. They also use the Ethernet and open standard protocols to provide the vulnerabilities, and compromising a CIS via a cyber incursion could have drastic effects due to that loss of the safety functions. These are some basic worries of cybersecurity. We can get into more depth here, but so what industries are impacted? Well, this impacts so many industries. I'm not sure if people realize it, but you can see here, there's power, there's petrochemical, it could be offshore, it could be chemical, medical, transportation, A big one in transportation is for automotive. You have robotics, and there's many others. And let me ask you a question. Do you remember that Jeep hack? If you don't, it was about a year ago, and two cybersecurity researchers, they remotely compromised a Jeep Cherokee. Kind of interesting. Now, they did this on purpose. Okay, this wasn't a harmful hack. This was something they were testing to see if they could do. Now, they were actually able to disable the car's transmissions, its brakes, and while the vehicle was even in reverse, they took control over the steering wheel. Now, they were all possible because they were abusing the existing functionality in that car. So when I say they did it in reverse, it's because that car could self-parallel park itself. So what it did, it took control of the steering wheel, right? Well, that gave them the ability then to take control of that car's steering wheel. Interesting, right? And basically commanded the vehicle to do things that were within that same vehicle's limitations. So it's not like they broke and made the car do things it wasn't supposed to. They just took control of the areas that the vehicle actually allowed it to do. Interesting. Now, what is automation security? Automation security is the prevention of unintentional or intentional interfaces with that proper automation operation of automation control systems, right? So this can be computers, this can be networks, it could be operating systems, it could be other programmable configuration components of that system. Now, when you talk about automation security also, it has many different names. You could call it SCADA security, PCN security. And once again, the acronyms there are down at the bottom. You have the industrial automation control system security. They call it the control system cybersecurity, industrial network security, and finally the electronic security for industrial automation and control systems. So you can see there's a lot of different names that people call the automation security. So we all find that most cybersecurity issues, they fall into three categories. First of all, control networks are full of what we would call soft targets, right? So the devices that are extremely vulnerable to disrupt through their network interface. The PCs in many plants run for weeks, for months, without any security updates, and some even operate without any antivirus tools. Think about that. I mean, maybe they just get in the way, but they don't even have antivirus tools on them. This is real world. In addition, many of the controllers in these networks were designed in an area when cybersecurity wasn't even a concern. So that, there's another reason there, and I'll show you in a future chart here, because cybersecurity wasn't a concern until like 10 years ago. But as a result, many of these devices can be disrupted by malformed network traffic or even by high volumes of correctly formed traffic. Secondly here, many networks have multiple pathways through which cybersecurity threats can enter the plant, right? So now these pathways often bypass existing security measures in that plant, and some of them, they don't even appear on the network diagram. For example, a laptop computer that's carried in and out of the plants, right? You're not going to see that one. A USB key that moves from one PC to another. These can easily bring malware into the plant and rapidly spread it to another system. All right, let's go to the next one here. Third, many networks are implemented as large, we'll call them flat networks, with no isolation at all between unrelated subsystems. This means that if a problem does occur in one part of the plant, it can spread very quickly to another unrelated subsystem and even to remote plant sites. So as you see here in front of you, this is the chart I was speaking about. You can see, I mean, cybersecurity until 2008, 9, 10 was close to non-existent. People didn't think about this. There's no ICS specific vulnerabilities, and that's why when I show you this next slide, 1980s, I mean, who would hack into a control system? This is why people thought that, because there was nothing there. There was no risks involved. Even in 1990, they're saying, you know what, maybe we should move the control into some type of, Windows platform and use, the Ethernet. In the 2000s, cybersecurity is recognized as an operational risk. And I think that's very interesting because even when you see this slide here, 2000s, I mean, there wasn't even a whole lot going on, but yet people still took still took notice to what was going on, and we give kudos to ISA 99 committee because they started working on a control system security standard back in the 2000s, which was so critical to where we are now. And even in the 2000s, presentations and conferences do demonstrate the ease of these types of attacks. So now we're getting into 2010 where everything started to evolve. And as you previously saw, and I call it the attack slide, right, that the bars were all of a sudden 2010, it rapidly increased. You can see that now there's like a cybersecurity war out there. And because of 2010s, all these different organizations started appearing, right? You have CIP, who's a critical infrastructure protection. They developed the REV. Then you have NEI, which is the Nuclear Energy Institute. They also have their own standards, which for them, they have cybersecurity plan for the nuclear reactors. They also have a North America nuclear plant. Then you have the International Instrument Users Association. You have ISA 99, which we spoke about for the security guidelines. And if you don't know, or sorry, I said, yeah, ISA 99. ISA is the International Society of Automation. And of course, you have the exida accredited cybersecurity certification program for personnel, products, processes, and systems. We kind of got into everything now, but and that's based off 62443, which we'll talk about. But this in 2010 was when STUXNET attack was discovered. And if you're not familiar with STUXNET, I threw a slide in here, but STUXNET, it specifically targeted programmable logic controllers, right, PLCs, which allow the automation of that electromechanical processes, such as those used in, let's say, control machinery on those factory assembly lines, amusement rides, even the centrifuges for separating nuclear material. Okay, so that's what it was specifically targeted for. And when you talk about STUXNET, it had 3 different modules, right? So it had the worm, and the worm, what it did is executes all the routines that were related to that main payload of that attack. Okay, it then had a link file that you didn't have to click on. It just automatically executed the propagated copies of the worm, and then there was a rootkit component responsible for hiding all the malicious files and processes preventing detection of this presence of STUXNET. Pretty smart, huh? And what's very interesting is that this was the first malware specifically targeting an ICS. And it was scary. It was discovered in 2010, but it was already in circulation a year prior to that. And it targeted the Siemens S7 PLC. And you can see in front of you that it did impact and infected thousands of PCs worldwide. And there's been approximately 24 cases reported on these types of systems. So really, what resulted from STUXNET? Good happened, right? Because the awareness. Now all of a sudden everyone's paying attention to the cyber attacks. We're trying to protect ourselves. But bad also resulted from this, besides even the implications of what STUXNET did to people. Because now there is a full set of STUXNET attack tools becoming readily available on the dark net. Whether you knew this or not, you could easily just search for it. And maybe I don't recommend you do it all the time, because then you might have someone looking at you wondering what you're doing. But even the development effort required for a sophisticated attack, right, like STUXNET, right, because you can see how it had three modules to it, very sophisticated. You couldn't find it. But this sophistication now, you can easily find it, and it's dropped to nearly nothing. There's not even a learning curve. You basically just take it, and then you can do whatever you want with it. The dark web is easy to get to. You can use a Tor anonymizer program. You can purchase these attack tools with anonymous payment systems, let's say like Bitcoin. And it's scary. I mean, it's not something that I'm going to, put fear into people, but really, it's that easy now that you can just do this. And, and another thing is, if you don't really know much about STUXNET, I told you a good amount, but the book that I showed you in front of you is probably one of our, it's a really good read, but it's not like Lord of the Rings or Game of Thrones. It is exciting, but you know, not that kind of exciting. All right, so now let's look at some of the cybersecurity certification schemes that are out there. ISA and exida, we do offer a large range of cybersecurity certifications that meet the needs of many different industries. Of course, here at exida, we do support both the original ISCI schemes and the newer exida schemes based on IEC 62443. We'll go through both types of schemes in this webinar, but you can see that the classifications that are offered are product evaluation. There's schemes for the system evaluation, for process evaluation for our product, and then also process evaluation for the system. And before we go into the details of those, I also want to mention that besides even getting your products and services certified, you got to start thinking about even your people. And so much that exida, you know, we have this CFSP program, but now it's opened up to cybersecurity, where there's now programs for people to get themselves right? So the companies need to have competent people know about cybersecurity. So that's why these programs here. So we have programs for 61511. We have programs for machinery in 62061. We have programs for 61508. And now, of course, IEC 62443, we now have certification programs for people. And much like CFSP, cybersecurity also has a suite of specialties, whether you're IT/OT, which could be your facility administrator, it could be your facility network architect, it could be an MOC coordinator, an MOC champion. You have your ICS process for engineering integration. Once again, that could be your corporate ICS engineer. It could be your ICS technology management engineer. It could be a corporate cyber program administrator. You have the process, operate, and maintain CACE. That, once again, that could be your facility automation engineer. It could be your corporate engineer, all dealing with cybersecurity. It could be your technology management engineer. You have ICS OEM. Those could be like your network equipment designer. It could be your hardware or your software equipment designer. And it even could be a packaged product engineer, right? And then, of course, you have your design, your operate, and maintain, all within robotics. These also, in the category of robotics, could be your facility automation engineer, could be your corporate IACS engineer. It could also be your corporate cyber program administrator within the robotics field. So, as you can see, even in cybersecurity, because it's growing so fast, all of these industries now need to have their own specialty because of this. On top of that, besides just doing the certifications, of course, you're going to get, you have to prove that, okay, yeah, sure, if exida wants to do this type of work, or if people are going to spend the type of money to get certified, they got to make sure that what they're getting certified to is correct and is going to help them in the future. And that's why, you know, for functional safety, we went to ANSI, and then, of course, we had to go back to them for cybersecurity. And so we did get reevaluated. We are accredited. They reviewed all of our cyber procedures, our technical competency, our knowledge, experience, and so much more. My apologies for that small certificate, but I promise it's on there, but it got really blurry when I made it bigger. But, you know, we are now accredited to IEC 62443, which is very exciting, but it's because this industry is growing so fast. Now, I am going to mainly read these slides coming up on the different schemes because they say exactly what I want, and I want to make sure that everyone understands the differences in these schemes, and we can share what's included. So with ISCI, the cybersecurity scheme, you have the ISA Security Compliance Institute, right? It's established the very first cybersecurity certification scheme in the industry, in the automation industry, which is a huge deal, huge undertaking. They did a phenomenal job, and even we were able and privileged to work with that committee as a technical member of that ISCI committee and as a contract requirements author. We also became the first certification body in the world to achieve this accreditation for cybersecurity underneath this scheme, which was very exciting. It's because we worked hand in hand with the committees. Now, in the cybersecurity scheme for ISKI, there's 3 different schemes. You have EDSA, you have SDLA, and you have SSA. EDSA is your Embedded Device Security Assurance. This scheme is applicable to embedded control devices. The requirements are based off of ISA 99 and documented in EDSA 311, right? So then you have SDLA, which is kind of like a subset to EDSA. This scheme is applicable to software development processes. It is included in EDSA scheme, but what's different about it is that it can be separated as a distinct scheme to allow manufacturers to achieve the important goal, right, to figure out their cybersecurity vulnerabilities without having to achieve a device certification, if that's what they want. And then, of course, you have SSA, which is your System Security Assurance. Now, this scheme is applicable to automation systems with requirements based on ISA 99, and the requirements are documented in ISKI documents, right? And what will be very exciting, and we anticipate this to be very soon, but these requirements will be updated to 62443 in the near future. So 62443, we can talk about 4-1. It is the security development process. This is a standard that specifies that the life cycle of engineering process requirements must be included for any product to achieve that certification. And it's very much like the functional safety standards, that these requirements are based on well-developed software engineering principles created that were started in the 1980s. And a great book, we love we love reference materials, was this one here in front of you called Structured Design. If you're interested in where all these software engineering, the pioneering began, this is one of the books that started it. Now let's talk about Microsoft, because Microsoft actually had a huge part in the development of protecting in cybersecurity. And they have a, they call it the Microsoft Security Development Lifecycle, right? The Security Development Lifecycle. So software engineering for security also has been developed over many, many years on the same principles with specific additions. Here's what Microsoft identified as the several key objectives. They said you need to reduce the number of security vulnerabilities. You need to reduce the severity of the remaining vulnerabilities, right? So you figure out how many you have, you reduce them. Then you say, of what you have left, how do you reduce the severity of the ones that you have left? And then how do you implement a strong software engineering process, and then use those design procedures and static analysis tools to eliminate any well-known vulnerabilities, right? And so that were their key objectives, and that's what exida learned, and that's what we implemented into our schemes. So when you look at it on 4-1, you have the security development process. It's kind of nice to put into a chart form where you can see there's 7 different practice areas, and then there's also 7 different foundation requirements. But for the practice areas, you can see the cybersecurity management, and it's very similar to functional safety. It goes over the entire process, the security development process. It's the whole thing. Then you have practice 2, which is your security requirements. You have practice 3, which is your security design process, right? Which actually talk to practice area 5, which is your security verification and validation testing, right? You have to go back and forth. But then 4 is your implementation. You have 6, which is your defect management, and 7 is your update management. Now, when I talk about your foundation requirements, and by the way, because I know I see some questions coming in here, this is more of a top level of what's going on and how it's evolving of 62443. All these specific topics, we are going to have many webinars in the future, so bear with us as we develop the content to put into these webinars. In the next few weeks, we're going to just pretty much start rapidly sending these webinars so everybody can get on the same page, and we can help wherever we can. So thank you. So with 4-2 now, you have the foundation security capabilities, right? We talked about 4-1. Now we have 4-2, which they now call foundational requirements. These foundational requirements are 7 of them, right? And you can see they're in front of you. Now, the interesting thing that I learned later, because I'm also getting rapidly up to speed in cybersecurity, is you have different security levels, right? SL1, SL2, SL3, SL4, and you see these numbers in those boxes. Well, if we say, let's look at, for this webinar, we'll say FR1, right? The identification and authentication of controls. SL1 says 10. So there's 10 requirements you must meet for security level 1. Then you see SL2, and it says 16 requirements. these requirements are actually incremental. So really there's 26 requirements in SL2 you have to meet. So you can see how quickly moving up the security levels, how the scrutiny is increased, right? So by the time you get to SL4, you're looking at 40, 50, 70 or so requirements for you to have to meet, whereas SL1 was only 10. So it's a significant change. It's a lot harder. So keep that in mind when you're looking to figure out what level you would like to try and to achieve. All right, so now that you learned a little bit more about 62443, we can kind of go into the schemes that now Exida also has to offer, which are similar to ISKI, right? And I'll explain to you why we did develop these schemes. And you see where the current standards are. And in 2-4, this was actually released a while ago, 2015. So this one's been out there. This one's a great one to base off of. But then you actually notice 4-1 and 4-2. These are the ones everybody wants. 2-4, there's great. We're moving very strong in that part of the standard. But 4-1, 4-2, these are actively changing. Now 4-1, we assume, and we had a question this morning, when is that going to be released? Well, you can't ever give a firm date when our standard is going to be released because there's a lot of stuff going on behind the scenes. But we do expect by the end of next week to actually see a final released copy. So we're very, very excited about that. We hope it happens. If not, it'll be shortly after that. But that's what FDIS means, by the way. It means it's in final draft. It's ready for your formal vote. And no changes or comments are allowed. You either can say yes or you can say no. So that's where that one stands. So we're very excited it's gotten to that point. Now 4-2, it says CDV on it, January 2017. What that means is it's committee draft vote. Basically means if you say yes, great, no problem. If you say no, you're still allowed to comment on that standard and say why you feel it should change. So there still could be some revisions. The most likely will be some revisions happening there. So the 4 different schemes that Exida has, we have the Exida Security Device certification. Now this scheme is applicable for your embedded control devices, for your network devices, for platform devices, and any application per 62443. We then have your system security, right? That was for your device. Now we have the system security certification, applicable to defined systems of operator stations, your controllers, your servers, your networks, any switchers or routers. We have your security development process, and then we have your security process, your system security process. The development process is that applicable to your software development process. It includes any applicable requirements for 4-1, and then the 2-4 system, pretend that's already out there. The next scheme for your system security processes is available, where this is a scheme that's applicable to your system integration engineering procedures based on 2-4. Because these standards change, Exida schemes are always constantly updating to be the latest and greatest because of how fast this industry is growing and how rapidly it's taking off. Now, when I say that our schemes usually go above and beyond, it's because the market is forcing us to. Because this industry grows so fast, standard committees can only go so fast. And the great thing is, because we get to be on these standard committees, we can help make sure the committees stay up to date with everything that we're doing, because Exida is allowed to move a lot quicker, right? We develop our own scheme, we get certified to our scheme, and then we're allowed to operate per that scheme. And we're allowed to operate to help those manufacturers get the services they need as fast as possible, right? And so there's 7 different things that we now incorporate that go above and beyond 62443. And I'm going to read through them. I'll try and paraphrase a little bit because you got them in front of you, but it's important to know the differences and what's now out there. But so for the product or system manufacturer, they actually have to perform now a network robustness testing. This must be done at the development stage, all right, for every public release of security critical software. And it's not sufficient for that test lab to perform this testing after that product is already ready for production release. And this is very important because this type of requirement, it does not identify issues in time for an effective corrective action. If you're already at a release stage, you're already too late. So we require that this network robustness testing must be done prior because normally that manufacturer will need to establish a cybersecurity test lab and perform frequent testing. And what we do at exida is we actually witness the testing before that production is released. Okay, so that's one of the things we do. Another thing is there is going to be surveillance audits. These have to be performed by the CB at regular intervals to ensure effective testing. This is something we already do for functional safety. We now just include it with cybersecurity, right? And for exida, it's every 3 years. We make sure everything's okay. If there's changes made, we want to see those changes. And we want to see, make sure the testing is still effective. It's still doing what it was supposed to be doing in the first place. Another thing is we have equipment failure modes. These impact security. These also have to be evaluated during certification using that FMEDA process and procedure, right? And that's something we also do in functional safety. So as you can see, a lot of these procedures for cybersecurity, it lines up very nicely with functional safety as well. And you're going to see a lot of trends here. So even this next one, practical system level certification requirements needed for the system or product are published in a user's document typically called a security manual. Well, if you're used to functional safety and you know how to and you got a product certified, you think, oh, that's just like the safety manual for functional safety. Right. This is a security manual. So now I envision people having a safety security manual or something like that, where they can just include both, and that way you don't double efforts. So you can meet a lot of the requirements as long as you're functional safety certified. You already meet a lot of the requirements for cybersecurity as well. 3 other ones. The software development process used to create the product must be a strong set of software engineering requirements. Your system or product must have implemented the security features of that specified cybersecurity level, right? Makes sense. And then, of course, the cybersecurity assessment report must be published on the exida website, same as we've been doing in functional safety. Now our SAEL site, which we'll modify for cybersecurity, you can now see those companies, manufacturers that are certified in cybersecurity. And of course, all these requirements are going to be put into a security case, much like the safety case we do for functional safety. Once again, you have a security case now for cybersecurity. So you can see a lot of the similarities there. And all of these schemes, because of our advisory board, which are the end users, the people that buy these manufacturers' products, they're the ones that are telling us where we need to go, how fast we need to go, and this is why our schemes go above and beyond. Because if we only did what the standard said, sometimes they don't make sense, and it's not a value to them to have those. So, in summary, I hope that was helpful for you, because certification has great benefits. A lot of these schemes are now available, whether you go with ISKI, whether you go 62443. Your cybersecurity certification, I mean, it's that validation by the third party to let your end user know how you're compliant with cybersecurity. Because what we're seeing now is that even your RFPs, your requests for proposals in many industries, this is becoming almost mandatory. We've seen it in 2 already, where the end user told the manufacturer, I must see certification in cybersecurity. How can you meet that? And so we're working with those manufacturers, but this is just going to be just like functional safety, where before, I say like 10 or 15 years ago, people were like, well, what's that SIL thing? Well, it's going to be the same thing here, well, hey, do you have that security level thing? Or are you certified to cybersecurity? It's going to be the same thing. Why? Because, I mean, you saw that chart. Cybersecurity, unfortunately, the risks are huge now. And so that's why we have what we have. The questions here, let me go ahead and answer a few of the questions. I'll see if I can get to 5 or 6 of them. I do appreciate everyone's time on today's call here. But so the first one is, how does cyber align with functional safety? Well, here at exida, we have found that, and I kind of mentioned it throughout, that there is a large overlap in the processes. Implementing cybersecurity into the manufacturer's current process isn't as cumbersome as many would think. We can actually help anyone interested in incorporating this cybersecurity into their process as easy as we can just perform a gap analysis for them, right? So we can then take what they have, look at where they need to be, and we could show, okay, here's how far you are from achieving that. Okay. Another one. ISA website refers to 62443. Why did you say that it will be updated? Oh, well, easy enough. Well, right now that these schemes are based on ISCI documents, right? However, we believe, or I believe, that that's all going to be updated soon. And I can only guess that they put 62443 on there because their website is also going to be, they intend to have these 62443, right? And we have members from exida. We're getting everyone on the same page. Like I said, things are moving so fast that you know, people are just trying to keep up, and that's why we're lucky at exida here that we can move faster and make sure that we have a great transition plan in place to help. Do you have certification program online? I believe you're speaking of personnel. We do have training that you could probably do online. But as far as the certification program, it's going to be just like the CFSP program, where you're going to have to go to a room, take a paper exam. We have to, because of the accreditation of 17024, we have to remain impartial. We have to, you know, remain anonymous. So that's why we have to do what we do. But it's going to be basically just like the CFSP. But if you go to, if you email me, I can give you all the websites so you can look around. But it's exidacace.com is the website for cybersecurity. But I can send it to you if you need it. Yeah, no problem at all. All right, let's get another question here. Are cybersecurity solutions mainly software, and or is it instrumentally involved? Yeah, it is mainly software, but depending on the security level, I mean, you could even have independent computers that are implementing the firewall functionality, and these are required. And I'm not even sure that even today's current architectures are even good enough for some of the high-level, high security levels. I don't even think some of that stuff's even developed to meet those requirements. So right now, a lot of people are just doing, you know, security level 1s because a lot of this stuff doesn't even exist to be that safe. But that was a good question. If you have an automation system which includes embedded control devices, can you get an SSA, this is for ISA, an SSI certification for the system before getting the EDSA certification for the device? Yeah, you can. Go ahead and get your SSA, and then you can get EDSA after the fact. That's no problem. When will final approval of version 62443-4-1 be ready? Like I said before, there's never a delivery date. exida hopes that it'll be end of next week. But once again, we are not sure. Anything can happen, but our fingers are crossed because that would be great to get that released. So thank you very much. I really appreciate your time. Here are some of the future trainings that are coming up. We do have some cybersecurity trainings as well, so if you're interested and you want to select a time or date, let us know. We're always open. These are not set in stone. We can move things around. Feel free. And what is the typical SL level for a field transmitter? I'd like to tell you, just go for SL1. That's what I see all across the board. And if I see anything different, I'll let you know. But SL1 is usually where everyone's starting with. I think that's a great point. I think that's what you're going to see across the board for right now, because technology is not even there for some of the architectures to meet these safety levels. But that's okay, because technology is rapidly increasing. Things are moving. But that's it. Okay, everybody, great questions. I really appreciate everyone's time. If you want the latest and greatest information, social media is where it's at. We're constantly updating, letting people know when the white papers are out, when new presentations are coming, when we answer questions. If you have webinar topics, go ahead, hit email academy@exida.com. Oh, one other thing, there's a white paper. I hope everyone's still on this. exida 61508 Cybersecurity Certification Program FAQs. Search for it, go to exida resources, white papers, find this, it's free, and this will go through a lot of the questions I went through on this webinar, and it's a great reference tool. We'll constantly update the white papers as well to help out. Thank you, everyone. I appreciate everyone's time. I always enjoy this, and I appreciate those questions too. Have a great day, have a great evening. Take care for now. Bye-bye.